Hey everyone. Today's lesson is going to introduce perhaps the most powerful application of math in the real world, something called creating mathematical models. Now, a mathematical model is basically using math concepts to represent, explain, and most importantly, predict real world situations. And mathematicians that can create accurate models are very highly sought after and are generally paid handsomely to do so. Now, as you will see, math models are not always perfect, and exceptions are definitely part of the real world. But if we look at the current situation we're in, mathematicians all over the world are trying to create models for the coronavirus, trying to predict how it will spread, how our efforts affect the spread, how long we'll have to maintain our social distancing policies, and so on. And the difficult part of modeling is all of the different variables that can affect things. For the coronavirus, you think about back in the early stages, we didn't even have tests developed, so we weren't exactly sure who had it. Another difficult part is people that are asymptomatic, meaning you can have the disease, but you don't show any symptoms, which means that you can spread it without even realizing it. Another variable are the underinformed people of the world who don't think that this is a real pandemic and don't abide by the guidelines. And let's be honest, it's hard to predict crazy. And there are obviously many more variables out there, which is why math modeling isn't easy, and people that can do it well are very much rewarded. So now we're not going to get that deep into modeling. We're going to start with the basics and look at one of the most basic math models in fitting a line to a scatter plot, which generally involves just two variables. And we use X and Y to represent. The first thing I want to talk about is what a scatter plot is. And I literally just typed in scatter plot examples into Google, and you can see these are a bunch of different scatter plots. And a scatter plot just shows how two different things are related. If you look at the second example, the labels are a little bit easier to read. You can see temperature in degrees Celsius compared to sales. So you can see generally as the temperature increases, the sales increase as well. So that's a trend that mathematicians might try to notice and try to figure out what that exact relationship is so they can prepare their supply for what they can sell. And just looking at a bunch of other things, I see simulation time to surface temperature. All right. Here's a height and weight. This one is year and local index. And without looking into these greater, I don't know exactly what the relationships are. But basically, people have data from these, and they are looking at how are they related. And here are here's a little bit of math behind the scatter plots. All right, so we talk about something that we call correlation. And right in the word correlation, you see the word relation. So it basically is going to describe the relationship between the two variables. So with correlation, it's very much related to slope. If you look at the first three examples here, you'll notice all of these say this is a positive correlation. And when we say a positive correlation, it just means in general, from left to right, those points are increasing. They're going up. So as the horizontal component goes to the right, which means it's increasing, the vertical component is also increasing. If you look at the ones on the bottom, these are called a negative correlation, meaning that as the horizontal component increases, the vertical component decreases, or from left to right it goes down. So once again, associated with slope. So that's a negative slope. Now the correlation, and there is something called a correlation coefficient, and that's what these R's represent. All right, so the correlation coefficient basically is saying how close does this data match up to a line. And 1 and -1 are perfect correlation. So if you look at -1, that just means you have a downward correlation, but 1 means it lines up in a perfect line. All right, so if it's +1, here's the +1 example right here. It is a perfect line going up. if your correlation was -1, like this example down here in the bottom, it means it is a perfect line, but going in the downward direction. All right, so 1 is perfect, and if there's absolutely no correlation at all, as we can see right here, the correlation coefficient is 0. So our scale basically goes from 0 to positive or -1. All right. It is a very complex method to calculate the coefficient, but what it basically has to do is the distance that each point is away from that line, and we call that the line of best fit. So the fact that a correlation of 1, every point is 0 away from the line, that means we're not taking anything away. But when you look at the 0.8 correlation coefficient, now we're getting some distance between the points and that line. And when we get to 0.3, we're getting more distance between some of those points in that line. Now, some of them are very close. Like this point is kind of far, but if you look at the other one that I went through there, that is extremely close. All of them here are generally really close to line, which is why a 0.8 is actually a pretty strong coefficient. But as I mentioned earlier in the introduction, if you can fit a line to this data, that's great, but it may not be perfect, like a correlation coefficient of 1. It may not be perfect. So even though you're trying to make a prediction using this line, you'll see almost every single one of these points isn't even on the line. So even though you make a prediction about something, there's a good chance that the actual point in real life will not be exactly what you predicted, but it should be pretty darn close. And that's the power of mathematical modeling. So let's go ahead and take a look at some of the types of examples that you will see on your ALEKS assignment. So this first one is a scatter plot shows the time spent texting and the time spent exercising by each of 24 students last week. So just, once again, 2 variables we're talking about, time spent texting and time spent exercising. And as you can imagine, the more time you spend texting, the less time you have to exercise. So that's why we have a negative correlation here. But let's go ahead and look at the questions here. So it says, for these 24 students, as the time spent texting increases, the time spent exercising tends to decrease, showing that negative correlation. Part B, for these 24 students, there is a negative correlation between time spent texting and time spent exercising. And the easiest way to determine if it's positive or negative, if they're moving in different directions, meaning as one increases, the other increases, as one increases, the other decreases, that's negative correlation, or vice versa. If one decreases as the other increases, that's negative. Positive means they're both going in the same direction. Increases and increases, that's positive, or decreases and decreases, that's a positive correlation. All right, now C, using a line of best fit, we would predict that a student texting for 4 hours would exercise for approximately blank hours. And what's important here is you have to look at the line, not the points that are given. So I can't write on the screen right now, but if you actually, let's do this. I'm going to take a screenshot, and let's see if we can write on it here. So it's important not to look at this point right here, because that's not the line that we're using to make predictions. All right, we're using the actual line, so we have to look at the line right here. So going up 4 hours, that equates to about 6 hours spent exercising, but it's a little bit less than that. So let me go ahead and go back to ALEKS here, and you'll see that it's not exactly 6, but a little less than 6. So we're going to go with 5.8 there. So we're using the line, not the actual data points. All right, so let's go ahead and move on to the next type of question. All right, so this one, we've got a scatter plot to show the amount of time spent watching television and the amount of time spent doing homework last week, once again by 24 high school students. And you'll notice a negative correlation, which makes sense. The more time you spend watching television, the less time you're going to have to do your homework. But this one wants you to draw a line of best fit. So we take our tool here to make a line. And it's important to realize it says it doesn't have to be exact. All right, remember what we're trying to do is we're trying to minimize the distance between all of these points here to the line. If I put the line up here, like, yeah, it's got a pretty decent slope, but a lot of the points down towards the bottom are kind of far away. And once again, if I put it down here, the points at the top are kind of far away. So we want to try to get right around the middle. All right, and if we do this, yeah, look at that. I can make that go through 5 points almost exactly, which is great, but that doesn't represent the trend. All right, that doesn't really represent the true slope here. So we want to make sure that we get something kind of like this. All right, once again, it doesn't have to be perfect. It's actually very difficult to do this perfectly by hand. That's why a lot of people rely on computers to calculate the lines of best fit for them to try to minimize the distance. But it's just got to be close for you to get this correct. The next type of question is talking about correlation. So remember, correlation coefficient, if you have a coefficient of 1 or -1, that means it's a perfect line. And if we look at figure 1, that's pretty much a perfect line right there. And it's positive, so that's going to have a coefficient probably of +1. All right. If we look at question number 1, actually let's look at question number 2, because that's the one that says which one appears to be equal to 1. So that's definitely going to be figure 1. Question 1 says which one is closest to -1. So the very first thing that we have to realize here is we need something that's going down from left to right. And the only one that's really doing that is figure 3. So that's the only one that can be closest to -1. And then 3, which data set shows the least evidence of a linear relationship? That's clearly 4. It would be very difficult to put any kind of best fit line for that one. And the last type of problem that you're going to see here is they've made a line of best fit already for a scatter plot, and they've given the equation. You can see the equation y equals 3.87x plus 15.52. So that's the equation that they got from the line, all right? And that's the model. So that's the model that they're going to use to predict what somebody's midterm score would be, dependent upon the time and hours that they spent studying. So if we look at putting 0 in for part A, because it says what is a predicted midterm score for a student who doesn't spend any time studying, so that means 0. So I'm going to pull up my calculator here. We can do this in our head just looking at the y-intercept, but 3.870 times 0, or 3.87 times 0 plus 15.52, that will give us just 15.52. So that's what we would type in here. We would expect that person to get 15.52% on their midterm score. For an increase of 1 hour in the time spent studying, what is a predicted increase in the midterm score? This goes back to our properties of linear functions. Linear functions basically have a beginning point, which this one is 15.52, and then a rate of change, or the slope. So every hour spent studying, you should expect these students' scores to go up by 3.87 points. And then part C, using this, all right, so if a student studied for 12 hours, what is the predicted score that they should get? We just substitute 12 in for x. So 3.87 times the 12 hours that they spent studying plus 15.52. We would expect that student to get a 61.96. All right. And then what's nice about models is you can see, all right, what is your desired score that you want to get? If you want to get an 80, if you look at this line, it looks like you need to spend about 16 and a half hours studying to get an 80%. If you want to get a 90%, you go where the line reaches 90, and that looks like you would need to spend about 19 hours studying. All right, so that's also how we can use these models. And finally, your assignment is on alex.com. It is called Scatter Plots and Correlation. There are 12 questions on this, basically 3 each of the 4 problems that we just saw. And as always, if you need help with this assignment or any other past assignments, you can always Zoom with me Monday, Tuesday, Thursday, and Friday. I'm available during your third period time or your office hours.